All right, today we're diving into a problem that, let's be honest, affects all of us. How do you get a group of people to make a decision that's actually good for everyone? We're going to look at some amazing new research that shows how just a few simple, smart questions can make all the difference.
So let's just start with the core question. How do you make a group decision that's genuinely fair? I mean, think about it. It could be something small like trying to pick a movie with friends, or something huge like a major project at work. It's always this tricky balancing act, right?
To really get to the bottom of this, the researchers use this simple and kind of brilliant analogy that they call the doctor's dilemma. Okay, so picture this. You're managing a hospital, and you've got a bunch of shiny new offices to hand out. To be fair, you do the obvious thing. You ask each doctor to just rank their top choices. You get back these neat, ordered lists. Seems straightforward enough, doesn't it? Well, here's the catch. A doctor might rank Office A as number 1 and Office B as number 2. But what that simple ranking totally misses is the intensity of that preference. See, for that doctor, Office A might be an absolute 10 out of 10, their dream office, and Office B, it might be a miserable 2 out of 10. That ranking completely hides the colossal gap in how happy they'd actually be.
And this right here, this gets us to what the research calls ranking's fateful flaw.
So what's really going on is a clash between two different kinds of information. On one side, you've got what's called ordinal information. That's just the simple ranking, first, second, third. Super easy to get. But on the other side, you have cardinal information. This is the real deal numerical value, the actual satisfaction score. It's a little harder to get, but that's where the gold is.
And here's the bottom line. When we just stick to those simple rankings, we're literally throwing away the most important information. We're risking a decision that looks fair on the surface, but in reality, it makes the group as a whole way, way less happy.
This problem actually has a scientific name, and it perfectly captures this hidden cost. It's called distortion.
So, what is distortion? Well, think of it as a way to measure the damage. It's the gap between the absolute best, perfect outcome, the one you'd get if you knew everything, and the outcome you actually end up with because you only had those simple rankings. It puts a number on exactly how much happiness you left on the table.
And trust me, that gap can be massive. Let's say the perfect decision gives the group 100 points of total satisfaction, but the decision you made using only rankings, it might only get you 40 points. That huge 60-point difference, that's distortion. It's the price you pay for not knowing the full story.
So, the big question is, how do we fix this? How do we close that satisfaction gap without having to ask every single person for a detailed score on every single option? The research zeroes in on finding a middle ground, using just a few really smart questions.
And this leads us to the exact question the researchers, Abedin and Shah, wanted to answer. They're basically asking, hey, what happens if we can just ask 2 or 3 or a few more questions from each person? How close can we get to that perfect outcome? In other words, what's the real power of asking just one more question?
Okay, so here's what we knew before this paper came out. With zero numerical questions, just rankings, the potential for a bad outcome is, well, it's unbounded. It could be a total disaster. Ask just one targeted question, and you're guaranteed a much better result. Ask 2, and the improvement is even bigger. But the real mystery, the big question mark, was what happens when you can ask a few more. Let's call that magic number lambda.
And that brings us to the breakthrough, the elegant solution they came up with, the optimal algorithm.
The beauty of this thing is how it learns as it goes. First, it asks everyone, what's your number 1 pick, and how much do you love it on a scale? Then, and this is the genius part, it uses those values as weights. Somebody who says their top choice is a 100 has a much heavier vote than someone who says it's only a 10. The algorithm uses these weights to find a small group of the most promising options, and only then does it ask another super targeted question about one of those. It's a cycle, right? Each answer makes the next question even more powerful.
And the result of this whole elegant process is, well, it's just beautiful. The researchers proved the maximum possible error shrinks based on this specific mathematical relationship. I know, it looks a little intimidating, but what it actually means is incredible.
So what on earth does that mean in plain English? It means that every single new question you get to ask, that little lambda, crushes the potential for error, and it does it exponentially. The bang for your buck on each extra question is massive. Going from 2 questions to 3 isn't just a little bit better, it's a giant leap closer to the perfect outcome for everyone.
Okay, so this is all really cool theory, but what does it mean out here in the real world? Let's take it from the lab and bring it into our lives.
The big central message here is so simple, but it's really profound. A little bit of the right information goes a very, very long way. You don't need to know everything about everybody's feelings on every option. You just need to ask a few perfectly chosen questions.
And this isn't just about doctors and offices, right? This could change how we do so many things. We're talking fairer ways to share resources, voting systems that might actually represent what people want, or even just making your team at work more efficient. Basically, anywhere a group's overall happiness matters, this applies.
And that kind of leaves us with this one last big thought to chew on. You know, we live in this age that is completely obsessed with big data, with grabbing every single scrap of information that we possibly can. But what if the real game changers, the biggest breakthroughs, don't come from getting more data, but from having the wisdom to ask a few, small, perfectly chosen questions?